Hey there YouTube, this is Trainman109. Today I have this cheap power supply I got off of eBay, and I really don't like the loud fan that it has. It's very annoying. Now this fan is not the fan that came with this power supply. This is a replacement fan, because the one that came with it was damaged in shipping. Right here where the label is, it broke off and the motor was separated from the frame basically. Now originally, I'm going to take this off for a second. Originally, there was a grill here and the fan was mounted underneath. And the fan was incredibly loud. So I thought, well, maybe I'll mount it on top and that'll give it more airflow. Didn't change it at all. Now this is partly poor design of the power supply, because all it has to suck air from is these little vents right here and the space between this terminal strip and the circuit board. So it's cheap power supply, poor design. So, and even just holding this fan out in there, it's very loud. So I'll get rid of that silly thing and bring in this larger fan that I salvaged out of a HP printer. And as you can see, it's suddenly much more quiet, which is very nice. And this is with the hole still the same size as the small fan. It's that much quieter. So what I'm going to do is take my Dremel with a cutoff wheel, and I already traced out the circle of the larger fan. I'm going to cut that out, drill new holes for the fan to mount to, and then wire up my fan. I'll have a quiet power supply. Now it's just for those of you who are curious as to whether or not my replacement fan is any different in sound compared to the stock fan that came with the power supply. This is the fan that came with it. And it's not as loud as this replacement fan, but it's still pretty loud. Now I'll show you what broke on this fan in shipping. I don't know if this will show because it's all black. Maybe it will. See how it's just, I guess something dropped on the box that this was in, and it's just shared the plastic right off. Now this fan does run, but since the fan sits above capacitors and resistors and all kinds of fun things like that, I just fear that, because the fan hangs like this, I'm just afraid that's going to drop down and start eating things inside the power supply. And their concern with that is there are heat sinks in there, which is why it needs a fan. If the fan fails and I'm not monitoring the power supply, or I'm not around for whatever reason, it could catch fire and burn the house down, which wouldn't be a happy thing. So that's why I'm not going to use it, because I'm just too scared it might fail. Okay, it's just a quick view of inside this power supply. Now the fan sits right above right here, and these are the two heat sinks I was talking about. Now I'm not real sure about electronics. I know basic circuits, but stuff like this I'm lost. But I believe these are called MOSFETs here and here. They switch voltages. That's basically all I know about them. And they get warm. But I do know that these heat sinks are cheap and poorly made. Here's why. This came out of the HP printer that the fan came out of. Now it's the same thing. The little component screws onto here. But what's different about it is it has these fins on the back. which dissipate the heat out away from it, and there'd be a cooling fan out here. Now what's silly about these is the heat is going to the outside of the case, and the cooling fan is pulling from the inside of the case. So it's just a cheap power supply. Okay, now I'll get on to making that hole bigger, which I'll do outside, obviously. Okay, I have now moved outside to the trailer. I have this piece clamped on. There's 2 scrap pieces of wood underneath it because it has this lip all the way around. I didn't want to crush it, obviously. Got my Dremel plugged in, safety glasses on. I'm going to cut this out. It's a little warm. Of course, I can only imagine why. Okay, so I made the rough cut on this thing. And I'm gonna take this. I can't see if that's showing up at all or not. This is a rat's tail file. Looks to be about 12 inches with a little wooden handle on the end there. It just slides on. And I'm going to use that to work down to the line because I'm way more accurate with a file than I am a Dremel. Now what I'm doing is instead of just going straight, like that, which basically creates a bunch of bumps in the surface because it's rounded, obviously, I'm going down and across that angle, and then again down across that angle, and that creates a nice smooth curve. Cutting on the push stroke, not cutting on the pull, because that will dull the file. Okay, so I finished filing the circle out. It's not a perfect circle, I know, but it's not the end of the world because this fan will sit on top of it, so no one's going to ever see it, so it's not that big a deal. And went out in the garage and held above the trash can, used a box knife to cut off all the burrs so it's not razor sharp anymore. It's still pointy, but it's not bad. Now there's still one hole right here from the original fan mount, and I'm still going to use it. I got one of the bolts I'm going to use to hold the fan in. Put that in. Take the fan, set it on top of that bolt. Then I'll line it up where I want it. And I don't have a center punch, but I do have a whole bunch of hardware. It's the 2-inch drywall screw. Make sure it's got a sharp point on it or else this trick won't work. Nails work too. And I'll use that as my center punch. So let's just line this up where I want it. I got a little small hammer here. It's centered in the hole. Okay, there's one. Should have grabbed the longer screw for this. But that's okay. I know I hit it several times on the first one, but the ideal situation, you only want to hit it once so it doesn't bounce around. Making sure these two are still lined up, because I don't want to punch this last one if these two aren't lined up anymore, if the fan had moved. And it looks good. And there's my 3 holes. Hey, it almost went free. This metal is so cheap. When I was cutting the burrs off, I could almost cut into it with the box knife. Okay, now let's just find an appropriate size drill bit, take this back outside, drill the holes. Okay, now I'm going to drill the holes. I have a 3/16 drill bit and got a piece of 1x2 scrap here sitting on top of the angle iron on the side of the trailer, so hopefully I don't drill into the trailer. And it also provides a backstop for the hole, so hopefully it doesn't tear out as bad. So here we go. I'm running my drill in the medium speed setting, just because that's what I picked. This metal is so soft. Okay, all done. Now I should just clean up my mess, go back to using a box knife over the trash can, knock all the burrs off. Then I'll mount the fan on my workbench. Okay, now for the moment of truth. Does it fit? Should fit. Put all the bolts through the fan first. Now sit down. Looks like it fits to me. Cool. Okay, now flip it over and get some nuts started on here. And I'll grab a screwdriver. And some grippers. The gripper on the nut and the screwdriver and the screwdriver hole. Put it together. It's a little crooked. That's better. It's okay, even if it is a little crooked. It's not like this is a high precision project here. Okay, I'm gonna get some tools out and try to figure out what I'm doing next. Okay, so I have my fan mounted to the top plate of my power supply, and you'll notice this bolt here is missing. The reason why it's missing is the nut was hitting the top of this capacitor and preventing the lid from sitting down the way it's supposed to. So I just removed the bolt. And I think you'll be fine with just 3 bolts on there. It's not like it's going to be under any stress load or anything like that. But now I'm warming up my soldering iron, and in the circuit board for the original fan, this was the plug for it. As plugs into the circuit board. Let me hold this up. Plugs in right there. Now this is speed controlled. I'm guessing it controls it by amp draw. I'm not sure on that. But anyway, I'm going to strip the wires on this, strip the wires on these. This white one is a heat sensor. I won't be using that because this doesn't have a heat sensor in it, the power supply part. But I'll leave the wire in there in case I ever salvage this fan for a different project. But I'm going to strip these wires, tie them together, solder them together, and put heat shrink above the whole thing. So here we go. Now, it would be a luxury if I had a nice wire stripper, but I don't. But these old school scissors have served me fine for a long time, stripping wire. Once I pull the case off, I just twist it together if it's stranded core. Obviously not if it's solid core. I'm just going back about ½ inch. Give it a little twist. Be careful not to squeeze too hard or you'll cut the wire clean off. There it goes. It does take a little effort to pull the casing off using scissors. But I don't want to go crazy with it and cut too deep and cut into the wire. I'll cut that one a little more. Maybe not enough. Try again. Okay, I feel it hitting the wire now. There we go. Twist it together. On to the red. That one came off pretty easily. Okay, I'm gonna get my heat shrink ready. I'm gonna cut it in half because it's way too long. Save that for a different project. And I'll cut this piece in half if I can. There we go. Now this piece is about 1.5 inches long. And I'll slide it over the wire. There's one. And there's two. Now I'm going to do what's called a linesman splice. Which means you take the two wires, put them together at an X in the middle of each one, and twist it in opposite directions. Okay, there's one. hold the other one at a different angle so hopefully you can see it. But again, just hold it halfway on each one, just like that. And twist them in opposite directions. And that one came apart on me, so I'll try it again. Working with this small wire, that tends to happen a lot. Okay. Hold on just a second. I'll get my homebrew third hand tool here. This is just a piece of 2x4 with some solid core wire and a alligator clip wire end on it. Nothing fancy at all. What happened was my alligator clip wire had broke. This end broke off of it. I thought, hey, I should probably use that for something. And here it is. Now, is that in the camera? Yeah, it is. Cool. See if my soldering iron's ready. And it is. There it goes. I've learned heating it from the bottom tends to work much faster. Let that cool for a second. Now I got that oscillating fan running. One, to get rid of the smoke, and two, because it's kind of warm outside today. And the casing melted a little where this clip was. That's pretty common. Put the clip back a little. Puts the clip further back that time. Trying to get rid of this great big blob. Come on, go away. There it goes. Now I'll slip the heat shrink over the first one because the second one's still a little warm. Hope this heat shrink isn't too small. Kind of looking like it is. Bummer. Okay, I'm gonna cheat just a little bit here. There's a big blob on here that's preventing it. Let's try it now. There it goes. Okay, there's one. Let's see if I can get away with the same little trick on this one. Squeeze it from one side and the other side, and let's try again. And it's getting cut on the casing. There it goes. Okay, I was a little worried there for a minute. So I really didn't want to take that pack apart. And I'll warm that up and I'll shrink it. There's one. You gotta keep the soldering iron moving, otherwise you will burn a hole in the heat shrink. Okay, now it's just let that cool, and a little bit of solder came off on this one. So I was being impatient using the tip. Oh cool, it'll just come right off. Nice. Alright. So, don't be like me. Don't use the tip of your soldering iron where the solder is to shrink your heat shrink, because it will rub off on your heat shrink. And one, it looks ugly, and two, it can short something out. Okay. Now the end of this wire, this is the thermostat wire that I'm not using, but I still do want to protect it, so I'm just going to wrap it in electrical tape. May as well wrap this whole thing up in one bundle, keep it nice and neat. Cut off the excess. Mush it all together so it's all nice and happy. Now I know it helps tremendously to stretch electrical tape, but these wires are so delicate and so tiny I don't want to push my luck. It in. Now before I put this back together officially, I'm going to test it. And it works. Cool. Oh, that fits perfectly. Nice. There's a little bit of wiggle room in this wire, but that's okay because it goes around that sharp edge right there. So it's probably a good thing it's got a little bit of slack in it. Now I'm getting out the screws that hold the case together. I have them saved in a special cubby hole in my hardware drawer. The reason I wanted to test this before I put it together is because half these screw holes are stripped out. I can get the screws out again, but it's a bit of a challenge. I originally got this power supply. It's a 12 volt power supply. Originally got it for some RGB color changing LED light strips. But the fan on it was just so loud that I replaced it with a different power supply. Then I started using it for a electrolysis tank. It has the power to do it. I believe it's a 30 amp, and it is. I just looked on the label. It is a 30 amp power supply. But the problem with using it for electrolysis is, again, it has the obnoxiously loud fan. So what I've been doing anytime I use it is I take this cover off and balanced this fan on top of two of the sides and then one of the capacitors in there. So I could think straight about other projects while this was doing its thing off in the corner. Okay, I'll test it one more time. It's moving here. Cool. So that is my solution for a loud power supply fan. Now I do understand that this probably won't work for most power supplies because they're probably engineered a little better than this one and things are packed in there a little tighter. But for this particular one, it works great. So thanks for watching. Hope you enjoyed. See you in the next video.